Welcome to Lecture 2.3, Multiplication with Fractions and Area of Triangle. So the rule is, the long story of it is the product of two fractions is the fraction whose numerator is the product of the two numerators and whose denominator is the product of the two denominators. So if A, B, C, and D represent any number, and B and D are not zero, then we have two fractions, A over B and C over D. If we multiply the two fractions together, you multiply the numerators, A times C, and you multiply the denominators, B times D. So let's try a problem. 3/5 times 2/7. So the rule is we're going to add the we're going to multiply the numerators and we're going to multiply the denominators. So 3 times 2 is 6 and 5 times 7 is 35. Let's try another one. 3/8 times 5. Now if you remember, 5 can be written as a fraction over 1. So we're still going to multiply just the numerators. 3 times 5 is 15. And the denominators. 8 times 1 is 8. Now what if we have three fractions? 1/2 times the quantity 3/4 times 1/5. So let's try it out. First we're going to take care of the parentheses. Remember your order of operation. So it's going to be 1/2 times 3 times 1 over 4 times 5, giving us 1/2 times 3 over 20. The next step, we're going to multiply the 1/2 by the 3/20. Again, we multiply the numerators, and then we multiply the denominators. So 3 over 40. Now occasionally we'll have a fraction and another fraction, and the result we'll need to simplify, we'll need to reduce because they'll have common terms on the numerator as well as the denominator. So let's try 15/8 times 4/9. So our end result is 60 over 72. So 15 times 4 is 60, 8 times 9 is 72. But I can immediately see they'll definitely have a 2 in common because they're both even numbers. So let's reduce 60. We need to get into its prime factors. 2 times 30, but 30 can be broken down. 2 times 2 times 15. 15 can be broken down into 3 times 5. 72 is 2 times 36, but 36 is 2 times 18. And 18 is 3 times 6, so it's 2 times 2 times 3 times 6. Both the top, the numerator, and the bottom, the denominator, have a 2 in common, a 2 in common, and a 3 in common. 2 over 2 is 1, 2 over 2 is 1, and 3 over 3 is 1. So those all reduce down to 1. Now you have 1 times 1 times 1 times 5 over 6, leaving you with 5 over 6. Now you don't have to wait until the very end to reduce or simplify your fractions. For example, -9/2 times 8 over 18. I'm going to reduce before I multiply. So -9 over 2 times 8 over 18. I know that 2, if I rewrite this problem all over one fraction, -9 times 8 and 2 times 18, I know that 8 over 2 will reduce down to 4, and 9 goes into 18 2 times. But now I have 4 over 2. I actually have a -4 over 2, and that will reduce all the way down to -2. So if you prefer to get your fraction into smaller and smaller numbers, reduce before you multiply. So again, let's reduce before we multiply. We have 2/3 times 6/5 times 5/8. So I went ahead and rewrote it all over one fraction. And just to cleanly, I'm going to write it in ascending order to maybe see it a little bit easier. But now I have 5/5. That's definitely reducible. 6/3 reduces down into 2. 2 goes into 8 4 times. And 2 goes into 4 2 times. But you do have to remember you still have a 1 on the top of the fraction. Now let's rewrite this fraction -3/4 squared. It is the whole entire fraction including the negative sign that is being squared. So we can rewrite the problem as -3/4 times -3/4. Multiply the top, which is -3 times -3, and 4 times 4 is 16. Alright, so now we have 5/6 squared times 1/2. Again, I'm going to rewrite the problem and expand the squaring. Now, if you don't need to, then that's fine. I just want to emphasize what I'm doing here. So now I'm going to multiply the numerators and the denominators, leaving me with 25 over 36 times 2 is 72. And it is reduced because I can see they have nothing in common when I wrote everything on top of one fraction. And we have a couple problems to simplify each expression. So first, I'm going to go ahead and rewrite the problem all over one fraction. And now I see that I have a -3/3, leaving me with a -1. Okay. Now I'm going to multiply the numerator. 2 times -1 is -2, and the denominator is 5. Again, let's go ahead and rewrite the second problem as -7/8 times -5/14 as -7 times -5 over 8 times 14. Now, if you see that you can simplify before you start your multiplication, go ahead and do so. Sometimes it's a lot easier to do it now. 2, and that's a -1. Now I can see I have nothing else to reduce, so I can go ahead and say -1 times -5 is 5. 8 times 2 is 16. Sometimes you'll get somewhat of a word problem. Find 1/2 of 2/3. You need to remember that of, the word of, indicates multiply. So we're going to multiply 1/2 times 2/3. And I can see immediately I can reduce, simplify. That gives me 1/3. Okay. And you kind of want to look at your answer and see if that makes sense. 1/2 of 2/3. Well, 1/3 plus 1/3 is 2/3. And if you cut it in half, you do get 1/3. So the answer does make sense. You always do want to look at your answer and see if it makes sense in the end. So what's 3/4 of 12? Again, the of indicates multiplication. So let's just write the problem. 3/4 times 12. But 12 is 12/1. So 3/4 times 12/1, just to be sure it is in a fraction form. Now I can reduce. 4 goes into 12 3 times. And I have 3 times 3 is 9 over 1, but we can just say 9. Now you've probably seen examples of this in the real world. If you go to the store and you have ever heard of the buy one, get one half off, well, that's exactly it. How would you figure out the price? You multiply it by 1/2, and that second pair of whatever it is that you're going to buy, that's how much the price is going to be on the second pair. Or it might be buy 3, get the third one for half off, or at third of a price. Now you can figure out how to apply this concept out in the real world. So here's an example. According to a 2009 Pew Research study, about 2/3 of American teenagers reported that they have been in a car where the driver used a cell phone in an unsafe manner. Well, I'm kind of thinking who hasn't, but in a math class of 35 teenagers, how many would we expect to have experienced this situation? So let's grab the information. What do we know? We know that 2/3 of American teenagers have been in a car, that this has happened, and 35 teenagers are in the classroom. So let's pull out the information we know. 2/3, and we have a total in our class, in this class, of 35 teenagers. So we're going to multiply it by 35. So we have 70 over 3, which is about, let's see, 3 goes into 7 2 times with 1 left over. 3 goes into 10 3, so it is 23 1/3 of the students. Well, you can't have 1/3 of a student, so we'll just say 23 students probably have experienced this. Now let's change gears for a little bit and start talking about geometry, specifically the area of a triangle. So I have a triangle here, and the formula for the area of a triangle is 1/2 times the base of the triangle times the height of a triangle. And we're going to use B for base and H for height. So let's find the area of a triangle where the height is 7 inches and the base is 10 inches. So I use my formula, area equals 1/2 base times height. B is now 10 inches. H is now 7 inches. We plug those numbers into our formula. 10 inches times 7 inches is 70 inches squared, and it's all over 2. So now we reduce to 35 inches squared. So why does the formula work? If you remember back, the area of a rectangle is length times width. Okay? If you can see that the height of our triangle is exactly the width of the rectangle, and the length of the rectangle is our base of our triangle. So if we say L equals B and W equals H, for the rectangle, our area is now B times H. But if you notice, this little rectangle here, the triangle is only half of it, as well as the rectangle on the other side is 1/2 of that rectangle. So in total, the triangle only takes up 1/2 of the area of the rectangle. Therefore, our area equals 1/2 times base times height. And this is for the triangle. That's why it works. So until next lecture, be seeing you.